Welcome to Alice in AI Land.
All right, everyone, get ready because we are going deep into AI reasoning today.
Ooh, yeah.
We've got this super interesting research paper from DeepSeek-AI,
Yeah.
and they're doing some really amazing things with their new reasoning models.
Uh-huh.
These models are learning.
Right.
They're evolving.
Yep.
They're having these aha moments.
Really cool.
It's like AI is starting to think more like us.
Yeah, it's really remarkable what they've been able to do at DeepSeek.
So how are they actually teaching AI to reason?
Well, the DeepSeek team, they're really pushing the boundaries with the reinforcement learning.
Reinforcement learning.
Yeah.
That sounds familiar, but
Maybe a little refresher.
it's kind of
That'll
like,
be helpful.
yeah, so imagine you're teaching a dog a new trick.
Okay.
You know, instead of just drilling them over and over again, you reward them.
With treats.
Yeah, like with treats and praise when they get it right.
Positive reinforcement.
Exactly.
Got it.
And that's essentially how reinforcement learning works for AI. Okay, so instead of just feeding the AI a ton of data,
Right.
it's more about letting it learn by doing,
That's exactly.
making its own mistakes and figuring things out.
Yeah, and what's really exciting is that DeepSeek has developed two, main models.
Yeah.
DeepSeek-R1 and DocSeek-R1.
Okay.
And they're both getting really impressive results.
Okay, so let's start with this DeepSeek-R1.
Okay.
What makes this one so special?
The 0 is kind of the giveaway there.
Okay.
It means this model has 0 pre-training.
So it's learning purely through reinforcement learning.
It's learning from scratch, yeah.
Wow, so no pre-training at all.
Nope.
That's pretty wild. How does it even begin to learn?
That's what's so cool about reinforcement learning.
Okay.
It starts with nothing, and it just builds its knowledge through trial and error,
Wow.
constantly receiving feedback and adjusting.
Oh, okay, I'm starting to get it.
And you know what's really fascinating?
Right.
The researchers actually observed this moment with DeepSeek-R1, where it seemed to have a real aha moment.
You mean like a sudden burst of insight?
Yeah, exactly. It's actually described in the paper.
Wow.
So the model, after some exploration,
Yeah.
suddenly shifted its strategy.
Mm.
Instead of rushing through tasks, it started slowing down.
Really?
It dedicated more time to actually solving problems,
Interesting.
reevaluating its approaches.
So it's not just solving the problem, it's figuring out how to solve it better.
Yeah, and this shift led to much better performance.
That's incredible.
Like it's learning how to learn,
Yeah.
So that suggests it could be developed.
Like a deeper understanding of its own process.
It might be developing like a very basic form of metacognition.
Metacognition in AI.
Yeah, the ability to think about its own thinking.
That's pretty mind-blowing.
It's still early, but this could be a stepping stone to AI that can strategize,
Oh, wow.
independently adapt its learning process.
Yeah, so that's DeepSeek-R1.
Right, but remember, we also have DeepSeek-R1 to talk about.
Okay, right. So how does that one differ?
Well, DeepSeek-R1 uses just a touch of pre-training.
Okay.
It's like a little head start.
So it has a bit of background knowledge to start with.
Right, to enhance its readability,
Mm-hmm.
but it still heavily relies on reinforcement learning.
I see. So did that approach pay off?
It did. DeepSeek-R1 actually performs as well as OpenAI's O1-1217 model on reasoning tasks.
Wow, but wasn't that one like super advanced?
Yeah, it's one of the most advanced models out there.
And DeepSeek-R1 is just as good.
And here's the kicker.
What?
It's actually easier to understand how it reaches its conclusions.
So DeepSeek-R1 is as good as one of the most advanced AI models,
Uh-huh.
but it's also more transparent.
Yeah, which is a huge advantage.
Yeah, definitely, especially as AI gets more complex.
That's what
We need to be able to understand how it's making decisions.
Exactly. We need to be able to trust it, right?
Right.
And, DeepSeek didn't stop there. They actually took DeepSeek-R1
Okay.
and they used a technique called distillation.
Distillation, what is that?
Well, imagine you have this master chef
Okay.
and they're teaching an apprentice.
Yeah.
Instead of overwhelming the apprentice with every recipe,
Right.
they just focus on the essential techniques.
The essence of their expertise.
Exactly. And that's kind of how distillation works with AI.
Okay, so it's about transferring the knowledge of a larger model.
Into a smaller one.
But it's more than just shrinking the model. It's
Oh.
teaching it to think like the bigger model.
Yeah. And you know what's really amazing?
What?
These distilled models, even though they're smaller, they actually outperform many larger AI models out there.
So smaller size, bigger brains.
Yeah, pretty much.
That's fascinating.
It's like size isn't everything when it comes to AI.
Yeah.
We might not need to keep building bigger and bigger models.
Right. Right.
Maybe we can focus on making them more efficient.
More efficient and easier to understand.
Exactly.
That would make AI a lot more accessible.
And that could have a huge impact on things like healthcare.
Education, scientific research, all sorts of fields.
Yeah, it's really exciting.
Absolutely. But you know what else I find interesting about DeepSeek's research?
What's that?
They don't shy away from their failures.
Oh, yeah, that's really important.
They actually talk about what didn't work.
It shows a level of transparency,
Yeah.
which is really valuable for the research community.
It's like they're saying, hey, we tried this, it didn't work, but here's what we learned.
Exactly.
And that can help other researchers avoid those same pitfalls.
And build upon their experience.
Yeah, exactly.
And one of their failed attempts involved trying to use more complex reward systems.
More complex reward systems.
Yeah, they wanted to see if they could really fine-tune the AI's reasoning process.
By rewarding it for specific steps.
Right, not just the final answer. So these process reward models, PRMs.
PRMs.
Yeah.
Okay.
It's a pretty cool idea.
So how do they actually work?
Well, imagine you're learning something new, like how to play the piano.
Okay.
A traditional approach would be to just practice a piece over and over.
Right. Until you get it right.
Exactly.
Yeah.
But what if your teacher broke it down into smaller steps?
Like focusing on specific techniques.
Yeah, like finger placement, chord progressions.
And they rewarded you for mastering each step.
Right, so you're not just focused on the end result.
You're focusing on the process.
And that's what PRMs do for AI.
Okay, so instead of just rewarding the AI for the right answer,
You reward it for taking the right steps.
like showing its work.
Yeah, exactly.
So it's about making sure the AI is thinking in a logical way.
Not just getting lucky with the answer.
But that sounds pretty challenging to actually implement.
Yeah, it definitely has its hurdles.
Like what?
Well, one of the biggest challenges is defining those reasoning steps.
The ones you want to reward.
Right. It's like trying to write a recipe for thinking.
That's a good way to put it.
It's hard to break down a complex thought process into, like, measurable steps.
Yeah, it's like trying to explain how you ride a bike.
Right. You just do it.
But it's hard to explain all the little adjustments you're making.
Exactly. And then there's this issue of reward hacking.
Reward hacking.
The AI might find shortcuts to get the reward.
Without actually learning the skill.
Yeah, like gaming the system.
So it's getting the right answer, but not for the right reason.
Exactly. So even though PRMs are really promising,
There's still a lot to figure out.
a lot more research is needed.
Well, I'm starting to see why that approach didn't quite work out for DeepSeek.
It's a tough nut to crack.
But they didn't stop there, right? They also tried Monte Carlo tree search.
MCTS.
Yeah, MCTS. What's that all about?
It's a search algorithm that's been really successful in games.
Like chess and Go.
Exactly. It simulates tons of possible moves and outcomes.
To figure out the best path to victory.
Yeah, like looking ahead and planning your strategy.
So they thought maybe this could work for language and reasoning, too.
Well, it makes sense, right?
Yeah, it's like giving the AI the ability to think ahead.
To consider different options and choose the most logical one.
But I'm guessing it didn't quite go as planned.
It turned out to be much trickier than they expected.
Why is that? Is language just too complex?
Language is definitely more complex than a game with set rules.
Right.
But the main challenge is the sheer vastness of language.
Okay, explain that.
Think about it. In chess, you have a limited number of moves.
Right.
But with language, you have almost infinite possibilities.
You can choose any word in any order.
Exactly. So scaling MCTS to handle that is a huge problem.
So did they just give up on MCTS?
Not exactly. They learned a lot from their experiments.
Even though it wasn't successful.
Yeah, they realized that techniques that work in one area
Don't always translate to another.
Right. It's a good reminder that AI research is full of surprises.
And even the best ideas can hit roadblocks.
But those roadblocks often lead to new discoveries.
That's a good point. So even though these approaches with PRMs and MCTS didn't quite pan out.
They still provided valuable insights.
Yeah, and I think it highlights DeepSeek's commitment to transparency.
Sharing both their successes and their failures.
Which ultimately helps move the field forward.
Definitely.
But I feel like we've only scratched the surface of AI reasoning.
Oh, yeah. There's so much more to explore.
And speaking of exploring...
Well, you should probably move on to DeepSeek's work on language model compression. Yeah, it's a pretty fascinating area.
I'm all ears, but first maybe a little recap on what language models are.
Right. So basically a language model.
Huh.
It's an AI system that's been trained on a massive amount of text.
Like books, articles, websites, that kind of thing.
Exactly. All that training helps the model understand
And generate...
human language.
It's a supercharged autocomplete, right?
Yeah, it can predict the next word in a sentence.
Write entire paragraphs, translate languages.
All sorts of things.
But these language models must be pretty resource intensive.
Oh, yeah. The most powerful ones are huge.
With billions of parameters.
Interesting trillions.
Wow, that's a lot of data.
And they require massive computing power to run.
So not exactly something you can just run on your phone.
Not yet, anyway.
And that's where this language model compression comes in.
Right. It's all about making these models more manageable.
More efficient.
Exactly.
So how do they actually compress something as complex as a language model?
Well, there are a few different techniques,
Okay.
but one of the most promising is called knowledge distillation.
Wait a minute. Isn't that what DeepSeek used for those smaller reasoning models?
You got it. It seems knowledge distillation has applications beyond just reasoning.
So they're using the same technique for compressing language models.
It's a pretty versatile tool.
So how does it work for language models?
It involves training a smaller model to mimic a larger one,
Okay.
instead of transferring all the information from the big model.
They're teaching the smaller one to think like the bigger one.
It's like an apprentice learning from a master.
Yeah, I like that analogy.
The smaller model learns to emulate the knowledge of its bigger counterpart.
But in a more compact form.
Exactly, and the results are pretty amazing.
Really? So how much can they actually shrink these models?
Sometimes by an order of magnitude,
Wow, that's like 10 times smaller.
and the performance doesn't really drop.
So smaller size, but still just as powerful.
That's the goal.
That's pretty incredible. What does this mean for the future of AI?
Well, for one thing, it could make AI more accessible.
More accessible,
Yeah, these compressed models can run on devices with limited power.
like our phones.
Exactly. You could have powerful AI capabilities right in your pocket.
That's pretty mind-blowing. What are some potential applications?
Think about real-time translation on your phone,
Okay.
or personalized education tools,
Tailored to your specific needs.
or even AI assistants that can really understand you.
It sounds like language model compression could change everything
It has the potential to revolutionize how we interact with technology.
and make AI a much bigger part of our lives.
It's definitely an area to watch.
Well, this has been an absolutely fascinating deep dive.
I'm glad you enjoyed it.
We've learned so much about AI reasoning from those amazing self-taught models,
The distilled models.
the power of knowledge distillation.
It's amazing how fast this field is advancing.
It really is, and it's inspiring to see the work being done by researchers like DeepSeek.
They're really pushing the boundaries.
Any final thoughts before we wrap things up?
Just that. It's important to remember that AI is a tool.
A tool that can be used for good or for bad,
It's up to us to make sure it's used responsibly.
to benefit humanity and not harm it.
That's a responsibility we all share.
Well said. And to our listeners, thank you for joining us on this incredible journey into the world of AI reasoning with DeepSeek.
We hope you learned something new today.
And that you'll continue to explore this fascinating and ever-evolving field.
Until next time, keep those minds curious.
And keep asking those big questions.